This is part 2 of section 2.6. Continuing with this problem, now that I have two things multiplied together and it's equal to 0, I can use the zero product property. So we're going to take x plus 2, set it equal to 0, and x squared minus 1 equal to 0. Subtract 2 from both sides, so x equals 2, negative 2. Add 1 to both sides, so x squared equals 1. And then I'm going to square root both sides. So square root, so I need to put a plus or minus sign in front of that. So x is equal to plus or minus 1. Okay, now notice the highest degree for this one was x cubed, so it was 3. So I should have 3 answers, and I have x equals negative 2, x equals a positive 1, and x equals a negative 1. Okay, now again, I've got 3 terms, 4 terms, 3, 4. Now I think of factor by grouping. So I'm going to move that negative 54 over to the other side. So let me get this written down. So I'm going to add the 54 to both sides. And then try to group them together. So I'll group the 3x squared minus 6x squared together. And then I'll group the negative 27x plus 54 together. So for the first group, looks like I can take out a 3 and an x squared. So I'm left with x minus 2. For the second one, looks like I can take out a 27. So negative x plus 2 equals 0. Now look at these. I've got a positive x and a negative 2 here, but a negative x and a positive 2 here. The only difference between the two are the signs. So if I do this right here, I'm not going to take out a a positive 27. I'm going to take out a negative 27 instead. So that will change this to a positive, and it'll change this one to a negative. Because when I multiply this negative 27 to both this one and this one, I'll get back a negative 27x and a positive, because a negative times a negative will be a positive 54. Okay? So then, now, with this group and this group, they both have a x plus 2 or x minus 2. So I'm going to factor out the x minus 2, and I'm left with 3x squared minus 27 equals 0. Okay, so come over here, two things multiply together equal to 0. Break them apart, set them equal to 0, and solve. Okay, so add the 2 over here. So x equals 2. Add the 27 over here. So 3x squared equals 27. Divide both sides by 3. So x squared equals 9. Going to square root both of them, so I need to put a plus or minus. So x equals plus or minus square root of 9 is 3. Okay, now notice the highest power here, we either have a choice of 3, 2, 1, or 0. So the highest one is 3, so I should have 3 answers. Well, x equals 2, there's 1. X equals positive 3, there's 2. And x equals negative 3. There's my third one. Now let's look at solving radical equations. So radical equations are equations that contain variables with a radicand, the expression under the radical symbol. Radical equations may have one or more radical terms and are solved by eliminating each radical one at a time. So just take it a step at a time. We have to be careful, though, when we're solving these radical equations. Sometimes you will run into an extraneous solution, which means that roots that are not actually there, or roots that are not solutions to your equations. Now, with all the ones that we just did when we had to take a square root, we should have checked all of those just to make sure we didn't have an extraneous solution. But on all of those, we didn't. Okay. But it's not a mistake on your part. It's just because you're raising both sides of the equation to a power, and it just kind of creates this new answer. But the only way to check to see and make sure that you don't have an extraneous solution is to plug each of the answers into the original equation and make sure you get true solutions or a true statement when you plug those in. Now, how you do this is we're going to isolate the radical expression on one side of the equal sign, put everything else on the other side. If the radical is a square root, then square both sides of the equation. If it's a cube root, then raise both sides of the equation to the third power. In other words, for an nth root radical, raise both sides to the nth root. What you're doing is you're getting rid of the radical symbol. Then you're going to solve the remaining equation. If you still have a radical term, repeat steps 1 and 2. 1 and 2. And then make sure you plug and chug your answers into the original equation and make sure you get true statements. Or just basically check your solutions. So let's look at this one. So number 1, we're going to isolate the radical, which is already isolated. I don't have any other terms except for my radical and the expression underneath it. So what I need to do now is, since it is square root, I'm going to raise both sides by 2, or we're going to square it. So what happens is the square root and the square will cancel each other out, because you can write this right here as this, x minus 7, this whole thing raised to 1 over 2. That means the exact same thing. If we had the cube root of x minus 7, we could write this as 1 minus 7 raised to 1 over 3. Whatever the root is, that will go on bottom. So basically what we're doing is we have x minus 2, it's raised to a half, and then what we're doing is we're coming back and we're squaring it. So that's like a 2 over 1, so we have a 1/2 times a 2 over 1. They cancel out, so basically they just go away. That's essentially what we're doing, or why this is working. Okay, so these will cancel each other out, or these will cancel each other out. You don't have to write that next step. So x minus 7, 5 squared, that's 25. So I'm going to add 7 to both sides, and that's going to give me 32. Now what I need to do is I need to check my answer, make sure I don't have a extraneous solution. So 32 minus 7, whoops, and I need the square root of that is equal to 5. Well, 32 minus 7 is 25. Square root of 25 is 5, so 5 equals 5. So that means x equals 32 is our answer, and we don't have an extraneous solution. Okay, let's look at this one. So our radical is isolated on one side, everything else is on the other side. So what I need to do is I need to square both sides. What will happen is these will cancel each other out, and I'm left with what's underneath. So x plus 3. And then what I need to do is I can write this like this, x minus 1 and 3x minus 1. And now I need to distribute this 3x to this 3x and this negative 1, and get x plus 3 is equal to 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. Then come back with this negative 1 times this 3x and times this negative 1. So I'll get negative 3x and a positive 1. So 3x, x plus 3 is equal to 9x squared minus, that's going to be 6x plus 1. Now what I'm going to do is I'm going to subtract this x to both sides. So I get 9x squared. That's going to be minus 7x plus 1. Going to subtract this 3, both sides. So I get 0 is equal to 9x squared minus 7x. And that's going to be minus 2. Now I'm going to use the short term or the shortcut trick when factoring trinomials that has a leading coefficient that's not 1. We have 9 in this case. I'm going to take the 9 in the last number, the negative 2, multiply them together and drop the 9 just for a moment. So that would be positive 18. Sorry, you don't include that negative. You just multiply the two numbers together, the 9 and the 2, so that would be negative 18 still. And then what you're going to do is we're going to factor this right here. So I have an x here, an x here. Now I need to break down 18 into two numbers that will multiply to 18, negative 18, but will add to negative 7, 2 and 9. And if one of them is negative, it will be negative 18. So it looks like we need a negative 9 and a positive 2. So 2 times negative 9, negative 18. Positive 2 and minus 9, that's a negative 7. Okay, so that checks out. Okay, so then what I need to do is come back and I took away this 9. I dropped it from here to here. I need to go back and divide both of these by 9. So now I have x plus 2 over 9. X minus 9 over 9, that's 1. All right, two things multiplied together equal to 0. I'm going to separate these out, set them both equal to 0, and solve. So this will be x is equal to negative 2 over 9. This will be x is equal to 1. Now I need to go back and check my answers for both of them. So let's check that negative 2 over 9. Oops. Okay, so this is over 1, and I need 9 on bottom, so multiply 9 over 9. So I'm going to have negative 2 over 9 plus 27 over 9, whole thing square rooted. This is over 1. If I take a 3 out here and a 3 out here, 3 out here, I'm left with a 3. And I left the 1 here. So it's negative 2 over 3 minus 1. So this is going to be 25 over 9. And I did that by 27 minus this 2 over 9. Gives me 25. I'm going to change this 1 to a 3 over 3. 25, square root of 25 over the square root of 9 is equal to, that's going to be negative 5 over 3. Okay, the square root of 25 is 5. The square root of 9 is 3. And then I have negative 5 over 3. Okay, but notice, over here is positive, over here is negative. So they don't actually equal to each other. So this is an example of an extraneous solution. Okay, let's go back and we check 1. Okay, so we're going to have square root of 1 plus 3 is equal to 3 times 1 minus 1. So this will be square root of 4. This will be 3 minus 1. Square root of 4 is 2. 3 minus 1 is 2. Hey, that checks out, so our only answer is x is equal to 1. Okay, let's look at this one. Now, the first thing we want to do is we want to isolate the square root to one side and everything else on the other side. Notice I've got this negative 2 on this side with the square root, so I need to move that over to the other side. Now, I don't have an example of this, so let me write this real quick. Say I had this right here. So the first thing I would do is I would move the 2 over, and you would have 5 times 3x minus 1 is equal to negative 2. Now this 5 is connected to this square root by multiplication. So in order to get rid of it, what we would do is divide both sides.